Okay, so here we have a little impromptu lecture on the nephron. I hope you'll find it informative. We start with the arcuate artery, bringing blood into the interlobular artery, from where the afferent arterioles will arise. The afferent arteriole will send the blood through a tuft of capillaries called the glomerulus, shown here in number 7, and then blood from the glomerulus will be drained by the efferent arteriole, shown here in number 4. And from there, the blood goes into peritubular capillaries that surround the rest of the tubular structure of the nephron. The blood from the glomerulus will be filtered into the Bowman's capsule or the glomerular capsule, shown here in 8. With the glomerulus, so 7 plus 8, we refer to that as the glomerular or Malpighian corpuscle. The filtrate, which is also referred to as ultrafiltrate, something to be discussed later, will be of lower osmolality than blood itself. When it comes through, it goes into the proximal convoluted tubule, shown here in 9, and from there, the blood will absorb the nutrients as well as a large portion of the water from the tubule as it makes its way into the interstitial gradient, shown here as number 15, which is arranged by the recycling of sodium ion. More on that later as well. Right now, just recognize that there is in fact an increasing gradient of salt, specifically sodium ion, outside the tubular structures and the peritubular capillary structures. So water will come out into the tubule and then be picked up by these peritubular capillaries. Eventually, the peritubular capillary blood is drained away by number 6, the vasa recta, and returned back into circulation. Meanwhile, the tubular fluid will have been resorbed about 80% of the original filtrate, and that means that we're talking about 180 liters of plasma a day that are filtered. 80% of it will be resorbed right here at the proximal convoluted tubule, along with nutrients like amino acids and glucose. From there, the fluid will enter the structure right here, shown here in number 10 as the descending limb, and even there, the water will continue to leave the tubule and enter the interstitial gradient, and only to be resorbed by the capillaries, and then the fluid is sent back up into the blood. The concentration of the tubular fluid with this resorption of water can reach levels of 1200 milliosmolal. However, when one gets into this next area, shown here as number 12, which is the ascending limb, we reach a limb of the tubule structures that is pretty much what we call impervious to diffusion. It's referred to as the thick segment of the nephron, which then extends all the way into the distal convoluted tubule and even into the collecting tubule. Now, what this term thick segment implies is that there is no diffusion allowed. There has to be specific facilitated diffusion brought on by hormonal action or the presence of ATP spending pumps are required. More on that later. The fluid will make it up into the distal convoluted tubule, and then as it comes around the bend over here, there is a drop in your water again, as more water will be resorbed by the interstitial gradient and then picked up by the peritubular capillaries. So the question is, how does the water capable of escaping from this tubule? Because we're talking about another 10% that was lost by the descending limb, but that still leaves you with a potential 10% of 180 liters or 18 liters that could be lost per urine. We actually wind up resorbing over 9%. So let's just say 9+%, leaving you with less than 1% that is actually used for the purpose of excretion of toxins by way of urine. So the question is, how does the water get resorbed if nothing can go through? Well, thanks to the action of ADH, the posterior pituitary hormone made in the hypothalamus, there are aquapores or aquaporins, however you want to use that term, aquapores or aquaporins, are responsible for being produced by the collecting tubule and then allowing for a way for water to escape into the interstitium. This then allows us to lose less than 1% of the volume of water from the ultrafiltrate. So we're talking about 500 to 1500 milliliters of water lost in the urine per day. This ends the discussion on the nephron in this segment.